Welcome, citizens of the globe, to the Frontend Heroes podcast, where we discuss all things villainous and heroic about the front end of software development. My name is Evan Payne. I'm a senior front-end developer at Actimel, and with me, as always, is my co-host, Scott Francis, a senior front-end engineer at Porsche. How you doing, Scott?
Doing really well. I managed to get out for lunch today, which is a real nice, normal person thing to do. So I'm in a super good mood, and it feels a little like summer's on the way. So all good.
Yeah, very good. Yeah, we had a rainy weekend, but it's clearing up, and mid-southern Europe, it's nice. Today's episode is sponsored by Netcentric, an award-winning Adobe Global Alliance partner headquartered in Switzerland with offices all over Europe as well as Pune, India. They are currently still hiring for a number of roles, so if you are looking, check them out. Scott and I used to work there. We love them. We are, as ever, so glad to have their support with this show. Today's guest is a front-end engineer at Salesforce. Nolan Lawson, will you introduce yourself?
Sure, yeah. So my name is Nolan Lawson. I work at Salesforce. I am a blogger about JavaScript, performance, browser stuff. I've been doing JavaScript for about, I don't know, maybe 10 years at this point. And I've published some open source JavaScript packages as well. So I've just kind of been around the area for a while.
Nice. When Scott invited you onto the show, I had already known who you were as well. Your articles do make the rounds, and you're a thoughtful person and a good writer. So we're glad to have you here.
Thank you.
The episode today is titled Performance Returns in the Superhero Vibe. And basically, we just want to talk a little bit about, some of the recent articles you've written and performance in general, and maybe thinking outside the box in regards to those things. So let's kick it off with talking about bundle size. And, my short form recap of your most recent article on your blog was that, a lot of people in the community, when they're thinking about performance, that they tend to go for bundle size, but perhaps that's only because it is the most accessible to measure lately. Can you maybe expand a bit upon that and what you think and recommendations there?
Yeah, sure. So just to give the kind of bird's eye overview. So I wrote this post called JavaScript Performance Beyond Bundle Size. And I started off with kind of this like classic story or parable that you may have heard about, the drunk who's trying to find his keys, and he's looking only in the street lamp light, right? And someone asks him, well, why are you doing that? He's like, well, that's where I can see. It's funny, but it's also like we probably all had moments like that just as human beings, right? Where like we just do the easiest possible thing. We take the path of least resistance. Like that's just kind of human nature. And I draw a parallel between that and a kind of trend that I've been seeing in web performance recently towards just focusing on JavaScript bundle size as kind of your key performance benchmark, right? Which to kind of and my assertion is that like we're focusing on that first and foremost because it's just the easiest to measure out of all the many different ways that you can measure the performance of a page. So it's not necessarily a bad thing, like as a quick like rule of thumb, or a shortcut to get an idea of the overall performance of the page. It's not necessarily a bad thing, but it can lead you astray if you believe that that's the only place that you're going to find your keys is right there in the street light.
Yeah, I mean, Scott, you've been really working more with performance than I have. So what was it that kind of resonated with you about this?
I think the overall feel of the article, because I think I've been guilty of analyzing like the JavaScript bundle before as like the be all and end all. I mean, I tend to have the philosophy that with performance, if you can really go after JavaScript and your images, then you're going to really see some performance gains if they're there to be won, if nobody's taking care of that. And so, yeah, I suppose that very much is looking for your keys in the streetlights. Like it really is. That's exactly that encapsulates it. And I think in the last year, I've done lots of work on performance, and that really is. And I feel like on my most recent project, at my now former company, I'd kind of got to the point where I needed to get more, like to focus in on performance. I'd done what I could with JavaScript. I felt like I'd done what I could with JavaScript, and I felt like I'd gone as far as I could with images. And then I read Nolan's article, and I was like, yeah, actually, he's right. But the thing for me is, I didn't know really where to step forward, and so
Okay, so let's be a little more practical then, in case listeners haven't found the article and don't want to search it or pause the podcast while they're waiting. So let's say you've read up articles on bundle size, so the compiled size of the artifacts that you're sending down the wire to the end user. That's fine. You've got that as under control as you can have it. But what other things should they be looking for?
Yeah, so that's where I kind of go into the nitty gritty details in the post. So yes, you're right. I would define bundle size as just the over the wire size of the JavaScript you're sending. So, are you sending 1 megabyte of JavaScript or half a megabyte of JavaScript or whatever the case may be, right? But the other metrics that I bring up are things like the parse compile time. So how long does it take to actually parse and compile that JavaScript? And to kind of take that a step back. So recall that the way the browsers work is when you stream the JavaScript to them, essentially you're streaming it in a plain text format, right? Like this is kind of one of the advantages of JavaScript. It's an interpreted language, and so the first thing the browser has to do when it sees those that's those strings, the first thing it has to do is it has to parse that into an AST or abstract syntax tree, which is sort of like the tree representation of the code. And then the next thing it has to do, it has to compile that into bytecode, which is sort of like a machine-independent binary format that is used for actually executing the code. And then beyond that, you may have also heard of things like JITting, just-in-time compilation, which compiles it then further into something even lower level called native code. But the two things it absolutely must do is parse into an AST and then compile into bytecode. So that all being said, that is something that, obviously kind of correlates with the over-the-wire size of JavaScript. It just tends to be the case that if you shove more JavaScript at the browser, it's going to take it longer to parse and compile that. But it's not always true, right? It's not always like a perfectly linear relationship between those two. So that's one metric, parse compile time. The other ones I bring up are execution time. Now you've finally taken that, that string format of the JavaScript, you've parsed it into an AST, you've compiled it into bytecode. The browser can actually execute some logic, right? How long does that actually take? Are you running a for loop that just loops a million times over something, right? That's obviously independent of how long it took to parse and compile that statement. So execution time is another thing. And then I go on and talk about also power, battery usage, memory, disk, and we can get into all that stuff later in the podcast. I don't want to overwhelm your listeners.
Yeah. Well, the one thing that I've appreciated is, over the years, the browser vendors and the people working on the JavaScript engines and the dev tools have given us better and better ways to measure these performance. I mean, maybe that's also that you tend to learn about them after you've already been doing this for a while. And I certainly know the measurements that you can do, just that the browser will just parse, and they're not. What is that called with the .now or?
Yeah, so there's a few ways to measure it. Performance.now is a good one. That just gives you just basically like the current time, but it's very high accuracy. It's what was the word they use? High precision, I think, is the term they use. Compared to something like date.now. So performance.now is typically the one you want to prefer in that situation because it gives you more granularity. There's performance.now, but then there's also performance.mark and performance.measure, which basically just allow you to declare a start and an end point of some span of time that you're interested in. I actually prefer the second one more, mark and measure, just because in the Chrome DevTools, it actually shows you like visually where that thing is. So you can situate it relative to everything else that's going on in your page and kind of understand, like make sure you're not fooling yourself, that you're actually measuring what you think you're measuring.
I think that's a really important thing, and in helping to actually understand like how your script is being executed and when things are running and whether things are doing more than you actually bargain for, basically. I did actually use the performance markers to on like a side project, and because I wanted to know like how quick does this really like execute? How quick is it? Because it's a script like that was running. It was away from like a main bundle. I wanted to know like definitely how quick is this going? And using those markers actually made things so much clearer to me and gave me so much like I could be 100% like I'm looking at this, I'm looking at the waterfall, I'm looking at the charts, and yeah, like I think many people would probably think that's like really overwhelming, but just adding my own markers made me see like no, this is right, this is where it started, this is where it finished, like, and it completely gave me more confidence, to be honest, in like what I was telling people about the performance of the code. So I think I would urge anybody to use those if they get the chance.
Yeah, and just to be a little clear on it as well, it's very similar to the debugger command, which is to say you toss it in, and as long as the browser API is there, which I think it is in a lot of the evergreen browsers, it'll just work for you. And again, it having that really high impact. I used it most recently I was implementing a memoization method of some sort to experiment, because a lot of those are hidden, right? They're part of like the Redux NGRX selector kind of concept. But I was like, okay, well, I'm outside of that system. In this case, I want to improve the time of this. Let me try and implement this myself and see if I'm right that it's going to speed things up. And I used this performance measure to prove it, and it was faster. So that's good. It proves the case.
Yeah, no, if folks haven't looked into performance.mark and performance.measure, they definitely should. Yeah, it's supported in all the major browsers now. There is a way of using it in Node as well recently.
Cool.
I think you have to require a built-in module, but that's it. And actually, if you've ever used, I think the built-in perf tools in React, if you've ever noticed, like you go into the Chrome Dev Tools, you go into the section called user timing. So user timing is just another name for the API behind performance.mark, performance.measure. They're actually doing this. And what's really neat is that Chrome draws it in a hierarchical way. So if you have like a React component that then has a child component inside of it, and that has a child component inside of it, it'll actually render like the hierarchy. So you get a really nice visual representation of where the time is being spent. And under the hood, they're just using performance mark and measure.
Yeah, it's really cool. I think Scott mentioned it, and I felt the same way as well. Those dev tools for performance-related things are so overwhelming at first. It's, like a pilot cockpit of like information being thrown at you. Do you have any tips to help kind of make it easier to get started on it besides the performance measure or performance.now? Or where to look for resources? I mean, I know resources, but it's more like how to ignore the stuff you don't need at first.
Yeah, that's a really good question. Well, to start it off, I would say that so in my blog post, I mostly just talk about the Chrome DevTools, which is what you're talking about. There are also other tools out there that folks might find a lot more accessible. So like one example is web page test. If you go to webpagetest.org/easy and just punch in a URL and press enter, it will load that URL and then give you basically the same information that you would get from the Chrome DevTools. And some folks might find that a little bit more accessible starting out. There's also Lighthouse, which is built by the Chrome team that does very similar things as well. It's usually just pretty easy to pick up and go. But in my post, I tend to prefer to use the Chrome DevTools just because I like to have that quick feedback loop of like I'm editing a page, I want to measure something, and I want to try something else, then measure that, and then try something else. One of the things I talk about in the post is you have to be very, very careful about how you do this. So I've seen lots of people just kind of pop open the Chrome DevTools and then and start trying to interpret what they're seeing, and they might come to a conclusion that's completely wrong. So like one example I give is that when I use the Chrome DevTools, I will always launch it in a guest or a private browsing window. And the reason I do that is because you probably have extensions, right? And browser extensions, they add JavaScript onto the page. And I can't tell you how many times I've started, analyzing a performance trace, and I'm like, why is it spending so much time here? What is that? And then I see it's LastPass or one password or some password manager or something. I'm not calling out any particular password manager. They all do something on the main thread. But, so I'm not trying to demonize any one particular password manager. But this is just to say that any extension adds some kind of overhead, and you don't necessarily want to be measuring your extensions.
I think that I think I'm right, but Chrome now actually warns you if you run the performance tool that you're actually that this could happen, that you're in a browser that has extensions, and maybe you want to switch to like an incognito to do it. Because like I was measuring something last week, and I'm pretty sure that I saw that, and it is something that I've done loads of times. And even though I knew not to do it, I still went back to it and still did it in the main thing. So yeah, it's just it is like little things like that. I think as well, something that you touched on in the article was actually not only starting in a incognito browser, for instance, like free of all the extensions, but also starting from a blank tab, like which I've got to say is like it seems like such an obvious thing now that somebody pointed it out to me. But when you're actually starting the performance recording, but you already have a page running, like it's nothing more infuriating than, well, where does this actually start? Like, not only I've got this huge chart and huge chunk of information, but like I just want the bit where it starts. So like starting from a completely fresh tab makes complete sense. And I think that would be a really good tip for anybody like who's like wanting to do some performance measuring.
Yeah, these are little details, but the details matter, definitely.
I was going to say it's important to actually use about blank as well and not just a new tab, because if you're like me, you have an extension that has a nice Google Earth satellite imagery for their new tabs, and that takes a bit to unload as well.
Yeah, I mean, I've run into this so many times where just like the like you said, the unload event for the previous page, you end up measuring that. If you're looking at the screenshots, it can be kind of confusing because when you're looking at the little film strip, you're seeing some screenshots for the old page and then a white page and then your new page, right? And that's confusing. Another thing you can do is in the Chrome DevTools, there is a little tiny refresh button next to the record button in the performance tab. And what that will do is that will reload the page and start the recording automatically, and then automatically stop it when it thinks the page is done loading. You can use this tool. One problem I've found with it is that it has heuristics to try to decide when it thinks the page is done loading, and it doesn't always guess correctly. But 9 times out of 10, it's correct. So that's another nice technique you can use.
You mentioned earlier on about the about web page test, and just thinking about going back to the waterfall again. But how would you recommend somebody starts to read that, to really understand it? I mean, you can dig down so much into JavaScript functions. So you say somebody sees a long task, and they know what a long task is. But then they're digging down to find the cause of that. How would you recommend that somebody goes about that? Because I think that's really something that could add a lot of value to somebody's performance work, but they perhaps don't know how to access that information.
Yeah, that's a good point. So talking about the Chrome DevTools, which is the tool I'm more familiar with, inside of that performance tab, you've got several sections. You've got the network section, which, as you said, is the waterfall of network requests, requests and responses, and that's also laid out against one that's called main, or the main thread, which is the primary thread where CPU execution happens for the most part. That's where your JavaScript happens. Primarily, that's where the browser calculates style and layout, and all these things are laid out kind of vertically. And so you have time on the x-axis, and then you have all these different ways of plotting things on that x-axis. One of them is also the user timings, the marks and measures. And then to your question about, if you see a long task in there. So a long task, the Chrome team defines a long task as any block of time spent on the main thread, contiguous block of time that's longer than, I think they say 50 milliseconds. which is based on some user research about, users don't want to click and then have to wait X number of milliseconds for that response. And so they say that 50 milliseconds is like, try to keep your stuff under that. And now, if you're looking at the Chrome DevTools, they will actually call out. This is a thing they added recently in Chrome. They will call out a little like a warning when you have a long task, when you have some block of time that's longer than 50 milliseconds, and they will warn you that you should probably try to break that up. And typically, what I would do in those cases is there's a few things you can do. First off, if we're talking like 60 milliseconds, like it might be like so small that you're going to get very high variance if you try to like run this over and over again. Like you might end up getting different results, right? So that's just one thing to be aware of. One thing you can do to limit that is in the Chrome DevTools, they also have the CPU throttling, where you can throttle your CPU to 4x slower or 6x slower. And one nice thing about that is that not only does it emulate, a slower device, like let's say more like a low-end Android device or mid-range Android device, depending on how powerful your developer machine is, of course. But it also just makes everything bigger and kind of easier to see, and in some ways more consistent. So what you might do in that case is you might bump it up to 6x, just so you can kind of like slow everything down a little bit. You look at your page in slow-mo mode, so it's a little bit easier to analyze. And then look at that block of time, and then just kind of compare vertically where that time is going. And you'll probably see something on the main thread, some JavaScript, some style layout, something along those lines.
That's a nice tip. That's a nice tip. I mean, I was aware of the throttling, but yeah, I never really thought of it that way. Like that you could actually just like see things in a more extended way. Yeah, I always tried to use it to obviously to replicate a slower device, a low end device, but never really thought of it in terms of it aiding analysis. So that's a really nice tip.
One thing that we probably should talk about, which isn't necessarily a tip and might require you to drastically rethink things, but it ties into part of your article, which is talking about power consumption or the CPU and how much you take. The project Scott and a few of our friends worked on, this progressive UX, is basically like a kind of development helper that can allow you to just add a HTML class depending on certain settings, so that your JavaScript can, or whatever you need to, can react to that, because it then knows the user's settings, device, whatever it might be. So an example of that would be, hey, this device that they're accessing your site from, right when the page loads, we know that it has a low CPU. And then you, as a developer, can choose to write or serve different JavaScript to them in response to that. Scott, I want you to talk a bit about that because you've been kind of running with it.
Yeah.
But also just kind of, this is a hypothetical brainstorming of how you'd actually break down the work and what you can do to serve different things. I mean, a lot of us are caught in this world of, hey, I'm using Angular, that's all you get. But how much can you move around within that?
For me personally, I mean, thank you for mentioning the project. Yeah, the whole idea of this was that that we use it not so much as a performance tool, more like a design tool. We wanted to give people the chance to know that they could adapt to different situations based on the performance of the current setup. We did that basically using like Navigator API for a few things. One of them is like the CPU capacity of a device. And I think that the aim for us was really that we started a conversation way before code took place. It took place at design stage. But then it also gave coders like a way of actually implementing those design decisions. And I think that with mobile devices, like that becomes really, really relevant, right? I mean, like it's interesting that we see in Nolan's article that power usage is something that we should code for. This does directly tie in with like the prog UX that we worked on. One of the, if we can get it so that a device, that a user conserves energy on their device, then we were thinking, to be honest, like we were probably thinking more in terms of like, oh God, like the user device is going to run out. We need to save them some JavaScript rather than like the initial performance, if you like. The two things for me are a little bit different. Optimizing your JavaScript should just be something you do, but then like minimizing the JavaScript that you send to give a different experience is kind of a different thing. Like it's a different approach. But I would say probably two sides of the same coin. With both instances are trying to conserve a device's power. So how
Yeah.
would you Nolan? How, with that in mind, how would you actually suggest that we measure the power usage, measure the performance of that?
Yeah, that's a good question. I would say the first thing is to make sure you actually have a problem first. Don't go hunting for dragons to slay that aren't there. So I've seen this come up in the past where a user would just kind of have their the task manager open in Windows or something, and they would just notice that this web page is sitting there and it looks inert to them, or it's just some web page laying out some text or something. It's not moving, but they observe that there's like this little CPU usage going on that's being detected in Task Manager. Like Chrome is taking up CPU, and they're like, "What's going on here?" Well, that is effectively just draining the battery kind of uselessly. And as you point out, this is something that's completely independent of your bundle size. It has nothing to do with how much JavaScript you're sending. It's with how you're using that JavaScript. And it also has nothing to do with your initial page load, as you mentioned. So if you use a tool like Web Page Test or Lighthouse, that's just going to measure the, unless you do some configuration, I think it allows for it. But by default, it's just going to measure how long it took to load your page, right? It's not going to tell you what happens after that page is loaded and appears to be inert and maybe sucking battery away, behind the scenes. So in that case, again, my tool of choice is the Chrome DevTools Performance tab. And what I tend to look for in these cases is not long tasks, because it's not really so much about long tasks. It's about repeated tasks. It's about, what I look for is, I'll just measure, I'll start recording while the page is just completely inert, right? And then in the trace, the timeline, I will look for like little blips of yellow or little blips of purple, like yellow being JavaScript and purple being style and layout calculations. And those might not be long tasks, like they might not take longer than 50 milliseconds, right? But if it's just kind of leeching battery by just running continually, then that can definitely be a problem, because that will just drain your battery, make your users unhappy if they open up the the task manager and notice what the page is doing.
What are the kind of things that trigger those, though?
Yeah, that's a good point. So I've seen a few different patterns that tend to cause this. Probably the one of the most common is someone has written a JavaScript library and they've implemented it in such a way where they think they have to continually poll, to continually check something. So like for instance, let's say it's like a custom scroll bar or something. It's trying to figure out where that scroll bar needs to be on the screen. And instead of listening for scroll events, that way it would only activate when the user is actually scrolling, right? Instead, they just they call set interval every X number of milliseconds, or they call request animation frame, which runs approximately every 16 milliseconds. And they'll just run continuously and check, what's my scroll position? What's my scroll position? What's my scroll position? And that kind of thing can trigger a style and layout. That can be very, very nasty, especially on a complex web page. And that can definitely leach battery just continuously. And basically in all these cases, typically what you want to do is you want to be kind of more event-driven, more reactive. So, if you find this happening on your page, what I'd recommend is looking into something like, intersection observer, which can tell you when some element has passed beyond some boundaries, crossed some other element, or resize observer, which tells you when some element has grown, to a certain size. Or just events like listening for scroll events, window resize events, that kind of thing, rather than just trying to poll every X number of milliseconds. The other major case where I've seen this come up is poorly coded animations. So there's kind of some very, very long-standing advice. Like I think in my post I linked to a post from like 2012 or something from HTML5 Rocks about high performance animations. And basically what it tells you is that if you're going to implement, a little spinner or something using CSS animations or whatever the animation might be, there's basically two CSS properties that you can use, which is opacity and transform. And if you use any of those other ones, like the browser might not have optimized that to run on the GPU rather than the CPU. And so it's going to be very inefficient. And if you got that spinner on the page, might just be leaching your battery. In some circumstances, even if it's not visually, like you don't visually see it, it might be, if it's somewhere in the DOM, it might be leaching your battery. So all those things can cause power drain.
Yeah, that's really good. Yeah, and I think that there's even, if you're being conscientious about these sorts of things, if you're already watching out for these, you learn that over time. It's part of what being an expert in the front end gets you, as more experience with that and so on. I think even like there's a drive to try and improve the user experience through things like delaying even API calls or preloading content. And the one thing that's always clicked to me about this progressive UX toggle, or it's a part of the browser's API of knowing if there's a low CPU device, is maybe don't make that call in advance. Maybe don't preload stuff if they're on a slower device already. Let them absorb the current content and suffer the delay, which they're probably used to anyway on a slower device, in exchange for like slowing down their experience when they don't know why. Something like that. It just gives you more choice, which I think is neat.
Yeah, unfortunately, like these things are hard, and like you're saying, there's fundamental trade-offs sometimes. Like for instance, between lazy loading and preloading, right? Like let's the idea of like let's lazy load any JavaScript we need until the moment the user clicks on the button. Okay, that's great. Now your users who don't click on that button don't pay that cost. But now when you're clicking on that button, now you're waiting and waiting after you click the button. So there's fundamental kind of hard trade-offs here that you can't get around. There are kind of ways to get around this. Actually, this is a little bit of a tangent, but there's a great post from Phil Walton on the Chrome team called "Idle Until Urgent," which basically proposes that if you're kind of stuck between like this idea of like should I preload, should I lazy load, sometimes you can do something kind of in the middle, which is like you can start to kind of load things using this API called request idle callback, which tries to look for points in time when the user is not doing anything, and then run a little bit of JavaScript there. And what you can do is you can then kind of preload stuff that way in a way that the user doesn't notice, so that then you're not, then when they click, it's already loaded, but they didn't have to like it happened when they kind of weren't looking. It's sort of like a sleight of hand. But fundamentally, like there's no such thing as a free lunch.
Yeah, and that's why we do this as a job, is because it is complicated and hard, and being informed of the decisions. I think that's great though that we have enough tools to really be informed about these things. I remember reading those articles on CSS and animations as well, and even things like the stacking context. All of this stuff feeds into this. Like, I didn't know that before. Oh, I'm horrified at my old code, which I think that's a good sign. If you're learning. And it's just a good time to be in the front end world. And I think it's only going to improve as well as we get better measurements. So in your article, you talked about most people focus on, bundle analysis because that tooling came first. But there are other tools that are growing and becoming more advanced in all the other bits and pieces too. So it's a good time to be working in the front end.
Yeah, I agree, and I definitely don't want to make people feel overwhelmed, like they have to go out and learn like 100 different things. I've been working specifically in the performance field for like 5 years now. I was on the performance team for a browser vendor for a while. So I was on the Microsoft Edge team, so I learned some of the dirty little secrets. And the main thing I would tell people is like, just measure. Don't kind of cargo cult. Like, it's really easy when you hear someone talking about like, oh, use this pattern instead of this. You can get caught in this kind of cargo cult mentality where it's like, oh, I have to always use a for loop that's like this rather than a for loop that's like that because this one is faster. And it might turn out that might matter, but it might only matter if, like, I don't know, you're building like a game engine and you need like things to render at 120 frames per second or something. Most of the time you just need to kind of measure your page, understand how to kind of read what your page is doing, and then go from there. You don't need to learn like the 1,000 performance tips and tricks, because it could be that only 5 really apply to your particular situation. So yeah, I would say, like,
I think that's
if you're feeling overwhelmed, that's what I would say. Sorry, go
yeah, I
ahead.
think that's a great point. Yeah, I think that's a great point that, like, of the not needing to know everything. I think this is something that we always talk about on this show. Like, don't beat yourself up if you don't know everything. Like, like nobody can. Like, there's so much to know. But I think that, to your point there, that like maybe it's a few things that you should focus on. So how do you feel then now about things like Core Web Vitals? As do you see those as like something that like that as a standard everybody can focus in and zero in on, and let's fix those, and Google are right that if we fix those 3 metrics, then basically people are going to get a good user experience in terms of like performance?
I think it's reasonable. Yeah, I think so. The Core Web Vitals are these 3 measurements from Google that they released a couple of years ago. What are they? It's help me out. There's uh,
Cumulative
On
layout
Scott.
shift.
cumulative layout shift. Yeah, I remember that one. And then
Yeah,
there's first input delay. Is that another one, or was it
it is. Yeah,
total blocking
yeah.
time? Something.
First input.
There's so many acronyms. Like I see. I don't even
No,
remember what they
no,
are off the top of my head.
no. It's first input delay, total blocking time. I think you in a lab setting, you would try and improve that one to improve the first input delay, because in a lab setting you can't replicate that.
Yeah,
Is
that's yeah.
is
You're
the
right.
theory?
Yeah, first input delay is only in production. Yeah, you're right. But there's a third one. So there's cumulative layout shift. There's first input delay, and then the third one is
Oh man, man, man! Come on! I know this. I know it. I know it. I don't know it. I'm
well.
googling. Um,
All right, go ahead and
The
Google it. But I mean,
university students that have this added to
yeah,
their
the
curriculum are
large.
yelling at us right
How
now.
can I forget this one? How can I forget this one? It's like the most obvious one. Largest contentful paint.
I remember
It's
that
because
one.
it's
Yeah,
like
Yeah.
because they used to have
yeah,
first
yeah,
contentful
yeah,
paint, and then they came out with largest contentful paint. I mean, here's the thing about these. I
yeah.
think that they're great. They're reasonable. What I noticed that they did, the Chrome team, is that they used to give you very granular metrics that were hard to translate into like something a real user experiences. Like, they're hard to explain to your boss, basically. Whereas now with things like largest contentful paint, it's like the biggest thing on your page. How long did it take for that thing to render? And these are almost like meta, performance metrics, because they're kind of built on top of lower level primitives. Like, obviously the browser has to do something to figure out what's the biggest thing on your page. Is it this block of text? Is it this image? Like, there's a lot of heuristics and magic going on in there, but it's easier to explain to the average person. Cumulative layout shift is like, how much does stuff kind of jank around, move around while you're on the page. No one likes the experience of like, I'm trying to click on something and then like something moves out of the way and an ad takes its place, and then you click the ad. That's super annoying. So no, I think it's neat what they're doing. I think it's very reasonable, and I believe they're tying it into like Google search rankings. So I mean, that's kind of a pretty big carrot that they're
Mhm.
giving web developers. Don't quote me on that. I don't remember the exact details. I don't work for Google.
No, it's happening. It's happening next month. Like
Yeah.
that it starts feeding in. Yeah, yeah, and like that's. I recently started in a new company, and already like I'm hearing people saying, "Well, what are we doing for the web vitals? Like we've got to get this ready for next month." I'm like, "Man, we should have like really this should be ready before then." I mean, that's a different kettle of fish, but yeah, it's definitely happening next month. So I'm of the same opinion as you, to be honest, Nolan. I think that for me, a lot of performance work is something that you have to sell to owners and to upper management and to clients, um, and these kind of things make it easier to do that, like the headline grabbing things, like things that they can understand.
I actually want to touch on that quickly, because we're getting closer to the end, so this will be maybe the last talking point. But um, specifically about, I think Scott and I work in two different types of companies, and Nolan, you and I probably work in the same, which is um, Scott's focus tends to be more on the actual like stuff that is indexed by Google, pages that SEO matters a great deal, versus more applications where you already have signed up, you've got the users, they're not going to find yours compared to something else necessarily. They're there for what your app does. And I wonder if working in both of those, that changes your nature, or maybe this core web vitals applies to both. I just want us to talk a little bit about the difference in mindset when it comes to performance in those two areas.
Yeah, that's an excellent point. I would say that in general, kind of all of the performance metrics in the browser that you can get have been very heavily focused on page load. So they've been more kind of focused on like the kind of like sites that basically the question of like when I click this link from Google, how or from Bing or from whatever, how long does it take for that page to load? They're less good at answering the question of I have a long-lived application and it's an SPA and I'm managing navigation myself. It's just we stay on the same HTML page the entire time. There's no true navigations going on in there. I would say in that second world, which I definitely live in that world in my current job. I would say the performance mark and measure is definitely your best friend there. You kind of have to declare like what is important to you. What do you consider a page transition? Like I mean, there's kind of some fuzzy stuff in there. Like when you open a modal dialog, is that a transition? I mean, some users would probably kind of perceive that as a transition or a navigation. Maybe the URL bar didn't even change though when you opened up that modal, or when you opened up this little side panel or something. So and I would also say in those cases that some of the other stuff I talk about in my blog post, things like how much memory are you using? That kind of stuff really starts to get important when you're building a long-lived application. Because you don't want like memory usage to just grow and grow and grow in this tab that's never getting closed. Because the user just kind of leaves it open for a long time, and then the browser just kind of kills the tab because it's exceeded its memory budget. So I would say that the tooling is a little bit harder for web applications, unfortunately.
Yeah, I think that's true as well. And I think, again, though, I like that Google's new approach, or, and in general, this mindset of you want to make the experience for the end user as good as possible. It's not going to be about these low-level things at first, right? It's the core web vitals was a breath of fresh air because it was like, oh, okay, that bothers me when that happens to me. Now I can have something a lot more practical to focus on because someone thought to measure that. It's nice, and that does apply across both applications and first load of content-centric pages. So it's nice. I'm yeah. My take on it would be the same. That the tooling that we've been talking about today is maybe more important for the long-lived applications, but that's not to say that those content pages don't also have performance implications that you can dig into this stuff with, right?
Yeah, absolutely. I would agree with that. Yeah. Um, yeah. Things like cumulative layout shift. Nobody likes it when stuff kind of flies around the page
Not a
and you're
bit.
trying to click on something. It doesn't matter if you're in a web app or if you're on a web page. It's not a fun experience.
Yeah. Right. So we're getting to that time of the show where we need to wrap things up. First, though, we want to go into our segment True Hero. In this segment, we'd like to highlight some true front-end heroes that are working across the planet and to thank them for all that they do. Nolan, you recommended us to nominate and put up Calvin Metcalf. Can you tell us a bit about why you did so?
Yeah, so I wanted to nominate Calvin because I feel like he's sort of one of these kind of like unsung heroes. So if you go to his NPM page, you'll see that he just has, I don't even know how many packages he's published, and plenty of them are getting millions of downloads a week. I mean, probably code he's written is in your bundle somewhere. Like he's written stuff like the if you call require process, which is a kind of node-ism, that then when you're translating modules from Node to the browser, then it has to be kind of browserified. Like it has to be some browser equivalent running. Like he's worked on that package, so that things like process.nextTick can just work in the browser. All these kind of low level things that like you'd probably only see if you actually just kind of inspected your JavaScript bundle from Webpack or something. You'd see his code in there. But he's just kind of he's worked on tons of stuff in that vein, and also just kind of personally for me, when I was working on the open source PouchDB project, he was involved in the project at that time as well. and he reviewed a lot of my pull requests and just taught me a whole lot about JavaScript back when I was still kind of learning. Like I was coming from Java and I was using some Java-isms that were wrong. He was very patient and taught me about the wild and wonderful world of JavaScript. So yeah, I wanted to nominate him sort of for personal and also for community reasons.
Yeah, I think that's totally appropriate.
Yeah, great reasons. Like, yeah, brilliant.
Yeah, I think there are actually a number of these kind of authors. Like, I don't know how to pronounce their names because usually just know them by their crazy GitHub handles, but that do these low level things, and the same way that Lodash is out there, and or underscore whatever you use that kind of all over. There are these things that all of that stuff that's in your front end bundle is built off of that these people put together. So again, thank you, Calvin, for all the work that you do. Next up, any proper hero is a well-rounded one, and so we like to share some simple musical picks. So, Scott, what's the favorite thing you've been listening to lately?
Well, I've not been too well-rounded this last month. I've not listened to too much music, but one thing that I did listen to was an album called Entertainment Death by Spirit of the Beehive. I honestly, like, I just started reading some reviews, and this was like rated like the best album in the last month. So I thought, well, I'll check it out then. And you know what? It's pretty good. It's not my usual taste, but it is pretty good. So I'd recommend giving it a listen.
Nice. Thanks for that. Nolan, what do you have in mind?
Well, the thing I've kind of been obsessed with recently, music-wise, is this genre called city pop, which was this genre that came out of Japan in like the 80s. And I've just been listening to tons of music from that era. It's sort of, you might kind of deride it as like easy listening, but to me it's just like, it's kind of like the sound of summer. It's got like heavy bass and like some horns in there. So I've been listening to artists like Maria Takeuchi and Tatsuro Yamashita. Like I would definitely recommend just like look up some city pop compilation and just tell me it doesn't sound like summer. Like I'm ready for summer, and to me city pop sounds like summer.
I'm definitely going to have to get onto some of that then, because I was saying earlier on, obviously, that I feel like summer's on its way. So yeah, definitely going to check that out.
Yeah. Awesome. Thanks for that. That's great. From my side, I was kind of struggling here to figure out. I wanted to maybe recommend Iron and Wine, but I'll save that for another time. So I'm going to do another weird one. This is very much like programmed music. The album's called Patterns of Consciousness by an artist named Caterina Barbieri. I don't honestly know how I even found it. Again, it's very much like programmed computer type of music. It's harsh on the ears, but also composed. Like she won some composer awards. So yeah, I don't know how to describe it. That's normal for my recommendations. But if it's up your alley, I hope you enjoy it. Great. So it looks like that's all the time we have for today, folks. Thank you so much for listening. If you enjoyed the show, you should like, heart, or star us in your podcatcher of choice. Reviews and ratings are how those fancy algorithms help people find our content, and the power to help is within you. If you have any questions or topics you'd like covered in our next episode, send us a tweet at Heroes Frontend, and we'll add it to our list. Until next time, heroes, remember, with great front-end power comes great responsibility. See you next time.